Does time really exist? If time could be looked at like a film strip, here you have a film strip, 7 days, seamlessly put together. Time is the act of motion. So let's say you have this strip, film strip, and you have from one frame to the other, similar to a wave, right? Connecting every frame together, creating the act of motion. It seems that way, doesn't it? But let's say that you want to freeze this day right here. So you take away this day and you freeze it. Now what are you freezing? What are you measuring? Is it physical? This whole day? So, for example, if the time is the act of motion, how can you freeze one day? Are you able to? Is it physically possible? As a matter of fact, you could say that time is more like a probable wave. I mean, if you think about it, if you try to freeze a day here, a particular day, you have stopped, you have frozen time per se. But in reality, what are you really freezing? Is it possible to freeze one day in time? To freeze the act of motion? Since time is the act of motion, if you prevent motion at one frame and freezing it, what are you really freezing? I mean, there's no such thing as a frozen moment in time. So where is the physical properties of time? Now, it's more, you could say that time is more like a wave, a probable wave, that if you attempted to freeze it here, you would create an uncertainty state, right? Because right here, if it's going from day to day, and then you decide to stop and freeze one frame, right here, you actually stopped a position, but you stopped in the process the motion. If you have a wave here occurring from day 1 to day 2 and so on, for example, if you have a day 1 here and it moves like a wave, right? If you decide to suddenly freeze this frame here, you have frozen the position of one frame of time. Thereby you created the act of motion from here to here, but once you stop this frame, the act of motion disappears. Or did it even exist in the first place? Because in reality what you have is, this is the now of day 1. 1 second, 1 minute, 1 hour, 1 day. It's all in the now. This is never connected to this. They're separated. Alright? In reality, they're just separated. Everything works in the now. And this this right here is a different now. And so is this. So on and so on. So there's no such thing as now and previous now. Think about it. If you have now occurring, well, how is it connected to this? It is impossible to connect two separated frames. These are all separated individual frames in the now. Not just the days, but breaking it down to the seconds. You have different, you're here, you have three, let me see, you have 60 seconds. Right here you have 60 seconds, which are 60 different isolated frames within this minute of nows. 60 seconds, 60 different nows within a second, within a minute I should say. Then you have 60 seconds in 1 minute, and then you have 60 minutes in 1 hour. That's 360, right? Then you have 360 minutes times 24 hours equals 12.17. You have 8,640 seconds in a day, which equals 8,640 different frames, if you're going by seconds only though, in 1 day. So you have 8,640 nows separated. Now every second, let's say, it's a different frame being isolated from the next frame. It's not a seamless connection of days. It's not. What is time? The universe is created by a conscious awareness state, i.e. life. The past exists only as ideas in the mind, which themselves are neuromagnetic events occurring strictly in the present moment. Time is the act of change, yet change is not the same thing as time. For example, if you want to measure anything's position, you will have to basically freeze it, 1 frame at a time. Yet, how can we freeze time, or the act of motion, since you cannot freeze one of its moments in time? Or can you? Well, because time is not a physical object that you can freeze into a stationary location. Therefore, what is time if it cannot be physically measured like a length? Can it be dissected into a smaller length, i.e. inches, for example? Distances between objects fluctuate depending on conditions such as gravity and velocity. Therefore, there cannot be any absolute consistent distances between anything and anything else, can there? Quantum theory suggests that distant objects are not truly separated. Why not, you may ask? Well, according to EPR experiments, entangled particles can act in unison even if separated by the width of a galaxy. You see, space and time are not physical, measurable, tangible entities. Rather, they are simply harmless illusions of the mind. There is no such thing as time. You cannot physically freeze it or physically measure it the same way you can real physical objects. You see, time can be described as a film strip, the act of motion. Now, if time is the act of motion, can you freeze the act of time? Or the past, for example? Any illusionary particular frame? No. Consider this. Since time is the act of motion, can motion exist independently without the act of time? In other words, can one of the sequential frames of historical time be frozen in place? The same way you can freeze a length measurement of a physical object as you measure half its length. In short, can time be half measured the same way a physical object is measured? Time is not a distance. The reason is that time is not a sequential length of events. It simply exists as an idea within our minds, I should say, which are truly non-physical neuroelectrical events. In short, can time be half measured the same way a physical object is measured? Time is not a distance. The reason is that time is not a sequential length of events. It simply exists as an idea within our minds, which are truly non-physical neuroelectrical events rather than physical objects, which occur only in the individual frames of the now. The observation act of time is not a sequential occurrence of events, rather it's a series of nows which create the illusional impression of sequential motion of time. Since time is a motion of time, it is impossible to describe motion when there isn't any physical properties to freeze within the framework of time. For example, if you throw a rock towards a target and freeze the motion of the rock in the mid path, you can then measure the rock's frozen position in time. But in return, you have lost the ability to measure the momentum of the falling rock. The path and its momentum have been lost, therefore unknown, at the cost of knowing the frozen position. Yet, how can you freeze time in mid-path as though it was a physical object?